Okay, algebra. I'm talking about unit 7. This is towards the end, talking about probability with combinations and permutations. What you need to be able to do is solve probability problems involving combinations and permutations. So let's take a look at what we got. Combinations, order does not matter. Permutations, order does matter. So make sure you can make those two distinctions. So a combination by clock requires a 3-digit code made up of the digits from 0 to 9. No number can be used more than once. So figure out the total number of ways first. So how many different combinations are possible? So if you cannot repeat it, so 0 to 9, that's 10 digits. But once I pick the first digit, I can't use 1 anymore, so there's 9 left. So then there's 8 left. So that's going to be 720 ways. All right, because once I've used a number, I cannot use it again. So what is the probability that all the digits in the code are odd? Well, then now you got to start counting odd numbers from 0 to 9. So 1, 3, 5, 7, 9. So probability is 5 odd numbers. Then there's going to be 4 left. Then there's going to be 3 left. Okay? So that's going to be 5 times 4 times 3, which is going to be 60 over 720, which simplified becomes, divide both those by 6, so that's going to be 1/12. There's your probability that they are all odd. Now, oh, hold on, I just want this. What is the probability that the first digit is a 3? So for the first digit, you've only got one choice. It's got to be a 3. After that, it doesn't matter. There's 9 letters left. Then there's 8 letters left. So there's 72 possible combinations out of 720, which simplifies to 1/10. Now, what is the probability that the code is 1, 2, 3? Well, there you've got one possibility. All right, you've got one choice for the first number, one choice for the second number, one choice for the third number. So that's going to be 1 out of 720. Because you've got one distinct code. There's only one option there. A word processing program requires the user to enter a 7-digit registration code made up of the digits 1, 2, 4, 5, 6, 7, and 9. Each number has to be used once, and no number can be used more than once. So look, you've got 7 digits, and there's only 1, 2, 3, 4, 5, 6, 7 numbers to choose from. So everything has got to be some combination of those numbers. So how many different registration codes are possible? Well, you've got 7 total digits. Each one's got to be used. This is going to be what's called your factorial. So 7 times 6 times 5 times 4 times 3 times 2 times 1. So your total number of possible combinations is going to be 5,040. Now, what is the probability that the first 3 digits of the code are even? So I've got to look at how many digits, how many possibilities are even. Well, I've got 2, I've got 4, and I've got 6. So the first 3 of the digits are even. So for those first 3 options, you know, how many, you got to think about how many choices. So how many even numbers do I have that could go in this first spot? Well, 3. Well, if one of them is picked, that means I've only got 2 left to go there. And once the first 2 are picked, I've only got 1 spot to go there. Then I've got the odd numbers left, and I don't care how they go after that. So this is going to be 144 over 5,040. Which simplifies to 1/35. So now, what is the probability that the first digit is 1? So again, I'm locking in what are my choices here. First digit has got to be 1. There's only one 1 available. That means I've only got one choice to go there. After that, I don't care. So I can go eight options for the second spot, 7 options for the third, and so on. So there's my choices. All right, and that's all going to be over 720. Oops. Oh, sorry, not 8. 6, 5, 4, 3, 2, 1. There's my mistake. Sorry about that. Divided by 5,040, you get 1/7. Simplified. It ends up being 720 over 5,040. I like simplified fractions. Simplified fractions to me make the most sense. Decimals are, they are what they are. What is the probability that the code is 1, 2, 4, 5, 6, 7, 9, the numbers in numerical order? Again, this is one possibility of everything that could happen. So it's easy. It's going to be 1 out of 5,040. So a group of 7 seniors, 5 juniors, 4 sophomores have volunteered to be peer tutors. Mr. Domingos needs to choose 12 students out of the group. How many ways can the 12 students be chosen? So 7, 5, 4, that is a grand total of 16. How does it matter if you get picked first or 12th? Are you still picked? Yes. Order does not matter. Doesn't matter if I could spell this morning. All right, so I want 16. Choose 12. So it's going to be 16 factorial over 16 minus 12 factorial, 12 factorial. So I'm going to multiply that. And I get 1,820 different possibilities, which I hope makes sense. That sounds like a pretty good number. What's the probability that it chooses 4 seniors, 4 juniors, 4 sophomores? So now you're limited, and you've got to pick 4 of each. So you've got to take 4 little mini combinations. So out of 7 seniors, he chooses 4. Out of 5 juniors, he chooses 4. And out of 4 sophomores, he chooses 4. This is a limited possibility all over the 1820. All right, so I'm going to do all these little combinations, multiply them together, and figure out what I get. So I want 7 choose 4, which is going to be 35. Then I want 5 choose 4, which is going to be 5. And 4 choose 4 is going to be 1. So that's going to be over 1820. So 35 times 5, 175 over 1820. Is going to be simplified to 5 over 52. Again, if you give me the big, long, ugly decimal, yeah, technically it's okay. It's not the best representation, though. Come on, you can be better than that. What's the probability that all 7 seniors are chosen? All right, so this is a little bit different beast here. All right, so you've got 12 spots. All 7 seniors are going to be picked. All right, so that means you've got, so out of the 12 spots, 7 are going to be seniors, and the other spots, the other 5 spots have got to be juniors. So that means 7 spots go directly to the seniors. So 7 choose 7. The other 5 spots go to the other 9 people. So 9 spots, 9 people left for 5 spots. All over that 1820 again. So 7 choose 7. Anytime you see one like that, it's automatically 1. So then this is going to be 126. So I get 126 over 1820. So I get 9 over 130. That's going to be my answer. So Diane has a bag full of coins, 10 pennies, 6 nickels, 4 dimes, 2 quarters. So let's take a look. How many ways can Diane pull 4 coins out of the bag? 4 coins out of the bag. She's got 10, 6, 4. She's got 22 coins. So I want to go 22, choose 4. So that's going to be 73,015 possibilities. Now, what's the probability that she will pull 2 pennies and 2 nickels out of the bag? So now these are all little mini combinations. So 2 pennies, 2 nickels. So out of 10 pennies, she's taken 2. And then she's also going to take 2 nickels. So 6, choose 2. All over 22, choose 4, which is what we got up here. So now I got to run these little mini combinations. So 10, comma 2. So that's going to be 45. 6, comma 2. Or 6 combination 2 is going to be 15. So I'm going to take 45 times 15 divided by 7315. So that simplifies out to 135 over 1463. So that'll be your answer. Now, well, the probability she will pull 4 pennies out of the bag. So out of all the pennies, she will pull all pennies out of the bag. So out of 10 pennies, she chooses 4. Out of 22 total coins, she chooses 4. So that's going to be 210 over the 7315. Again, I'm just pulling from up here. So that simplifies to 6 over 209. All right, last one. What's the probability she will pull 4 dimes out of the bag? Well, how many dimes do I got? I have 4 dimes total. So the probability I'm choosing pulling all dimes, well, out of 4 dimes, I take all of them over 22, choose 4. Remember what I said before, anytime you have a combination of the same number, it's just going to be 1 over 7315. So you've got one shot to pull out 4 dimes. All right, so finish this off and then go and take your quiz.